Now let's graph a secant function, 2 secant x plus pi. Let's take a look what kind of transformation we have here. But before we can draw the secant or graph the secant function, we have to graph our guide function. And the guide function for the secant function is y equals 2 cosine of x plus pi. So we graph the cosine function first, just like we learned before, and then we graph the secant function. Let's identify the important parts first. We have a, the amplitude is equal to 2. B is equal to 1, so that makes our period 2 pi over b, which is 2 pi. Our x increments, 1/4 times 2 pi. Let's make that over 1. That is equal to, we can reduce pi over 2. And we also have a phase shift here, so we got to figure out where does this cosine graph start. We need a starting point. And our starting point we find by setting x plus pi equal to 0. If we solve for x, we get x is negative pi. So that is our starting point. Okay, so negative pi right over here. Let me also make a little t-table. 5 key points, so we're starting off with negative pi. Now, we add pi over 2, the increments to it. So negative pi is really negative 2 over 2. Negative 2 over 2 plus pi over 2 is negative pi over 2. That's our next point. And then plus pi over 2, we get 0. Plus pi over 2, of course, that is also pi over 2. Somewhere here, plus pi over 2 is 2 pi over 2. And 1, 2, 3, 4, 5. We got enough points right here. Okay, so we have our x values. Now let's find our y values. Remember the basic cosine function. The y values start with 1, then it goes to 0, then we go to negative 1, back to 0, and then back up to 1. Our amplitude is 2, so if we multiply these basic y values by 2, we have the y values we need for our cosine function. So we start at 2, then we have 0, negative 2, 0, and 2. 1, 2. Negative 1, negative 2. That's a 1. Okay, let's start graphing. Negative pi is 2. And then we go to 0. 0, negative 2. So y-intercept. Pi over 2, 0. And then we go back up to 2. So we can see one full period. Now that we have one full period, that really does not give us a good representation of the secant. Actually, let me just make this a little dashed cosine, because the one that we actually need to graph is the secant function. Now what I'm doing is I'm adding another period to it, so we have a good representation of our secant. 2 pi over 2 plus pi over 2 is 3 pi over 2, 4 pi over 2, 5 pi over 2, and here we have 6 pi over 2. So we go plot these points, 0, negative 2, we go back up to 0, and we go up to positive 2. This now is our second period of the cosine. Oh, I wanted to make it dashed, but that's okay. I just use a different color. So what we really need to graph is the secant. We have our guide function. Now wherever this cosine function is 0, we start drawing our vertical asymptotes, like so. And you can probably hear this. Yeah, or I can make some noises too. Here you go. So we draw our vertical asymptotes on each spot where the cosine function, our guide function, is 0. And now we graph our parabolas where we have a maximum. We go up, and where we have a minimum, the parabola opens down. And here we draw a parabola that opens up and opens down. Ugh. Squeegee noise. And we have 1/2 here. Let me see if I can get a different color. So the graph that was important that we need is the secant, and this is what I'm making green now. Here you go. Secant functions, we first graph the cosine as our guide, and once we have the cosine, we draw the asymptotes, and then we can put our parabolas on top. And that's how you graph a secant function.